The Earth is warming, but how do we know it is changing our weather, and how do we know that it's human caused? That's why I talked to a meteorologist and climate expert, Shel Winkley from Climate Central, about his latest research and attribution science in relation to climatology. Hey there, Shel. Thank you so much for talking with me here today. You just put out this new article recently here from Climate Central about attribution science. And I want to talk to you about that and just how that relates to climate change here. So, can you explain to me about just a little bit of background on this?
Yeah, it goes back to that idea for so long. We always heard that we can't link one weather event, one specific heat wave, one hurricane to climate change. And in this case, we're not saying that a hurricane was caused because of climate change or a heat wave was made because of climate change, right? Like that heat wave was always likely going to happen. I always like to say a hurricane is gonna hurricane.
Mhm.
But what attribution science helps us understand is how much more likely or how much more intense was the extreme temperatures that you felt, was the wind and the rainfall associated with the hurricane, right? So take one of the most recent that we've had is Hurricane Melissa. We understand that the ocean temperatures were exceptionally hot, even for the end of hurricane season, even for the Caribbean. And we can use attribution science to understand how much more likely that unusual heat, which in turn ended up boosting the intensity of that hurricane. How much more likely were those temperatures because of the human aspect, because of the carbon pollution we've put into the atmosphere? And maybe this is jumping ahead of the conversation here, but you know, 90% of the excess heat that we as humans put into the atmosphere through that carbon pollution absorbs into the ocean. And that's how those ocean temperatures warm. And that's how we can confidently make these statements so that we can use that information to understand how we've made these natural processes, these natural disasters, a little unnatural.
And so I guess I got to ask one of the questions you probably get a lot is how do you get that baseline? So you're telling me that us as humans are changing the atmosphere. So how do we get that baseline about how we know where it would be without us versus where we are right now? Where's the data come to kind of show that difference?
Yeah. Okay. What we're doing is essentially we're comparing two worlds. We're comparing the unfortunate carbon pollution world that we're living in today to a simulated world that, yes, would probably have a little bit of extra CO2 in our atmosphere because one thing we always hear is carbon is very natural, right? Like
Mm.
we are part of that as human beings. That is a natural thing we see on Earth, but we also know just through years of measurements and being able to look back into the past of the Earth through ice core drilling, tree rings, whatever. We understand that the amount of CO2 that we have put into the atmosphere is at an exponential rate higher than we have ever seen in the course of the Earth's history. So, what we can do, we can take the data that has been so meticulously recorded over decades of time. We can take that and go back to the Industrial Revolution when we began putting extra carbon into our atmosphere. And so, what we're doing is we're essentially looking at those two worlds. We'll run a forecast or the climate data that we have once we understand the exact temperatures that occurred, and we'll run that through over 20 models, climate models and forecast models together. But then we'll do it again, but this time we're going to we're going to turn the dial down of all the extra CO2 that we've put into our atmosphere. And when you have these two calculations side by side, we can create a ratio. And then that's going to create what we use here at Climate Central, which is called the climate shift index. Right now, we can understand the likelihood, how much more likely a land temperature is on a scale from -5 being a temperature like that is going to be almost completely impossible as we continue to warm our planet in the future, to 5, which means a temperature like we're experiencing now would have been almost impossible without climate change. We can do it for the ocean temperatures, like I mentioned. Now, because it's harder to change our ocean temperature, right? You can get a cold front and temperature changes within hours. In the ocean, it takes
Mm.
something really big or it takes several weeks in order to really change our ocean temperatures. So that scale we can be even more confident with, and we can say anywhere from negative 1,000 to 1,000. That's just doing the day to day stuff. There's also extreme weather attribution. So we can look back after hurricanes like Helene, like Milton. I mentioned Melissa. We can look at flooding events. We can look at different extreme weather events. And we can say, okay, we understand that this much of this was just weather, but now this much percent is because of human caused climate change. But what I really think is the most interesting part, I was going to say exciting, but I don't know if that's the right word to capture it. But the most interesting part of attribution science, because let's say a hurricane hits you there in Florida. We see the destruction, we see the flooding, storm surge, everything that comes along with it. Let's say we do an attribution study to understand, sure, there was this much percent more wind, there was this much percent more rainfall. Well, that's happened with this storm. Just not to put the bad juju on you, but I'm going to call it Hurricane Robert, right?
Okay. All right.
Okay. So
Oh
now we
my.
understand what Hurricane Robert did to Florida.
Mhm.
But what I really think is interesting with attribution, because that storm happened, it's done, it's over with. It is good to know that climate change did or did not influence this hurricane. But what we can now do with the science is say, okay, and we know, we're in a world of 1.3 degrees Celsius above the pre-industrial average. What is a world that's maybe 2 degrees Celsius hotter than what it was back in the 1800s? What does it mean for a similar storm? And so we can use the science to understand, okay, now at 2 degrees of warming, now we're going to add another extra this much of wind and another extra this much of rain. And so what that tells us is that yes, extremes are becoming more extreme, but it also informs us. It tells us if another storm like this were to happen, how do we build our communities? What do we need to prepare for the future? But also it informs us of why we should dial back that CO2 ourselves so that
Mhm.
we can hopefully avoid that as we go into the future.
What could we do as a society to kind of reduce some of these broader impacts? Are we at the, because I keep on hearing the term tipping point, and everybody says, have we hit that? Is there any redemption for the humanity? Is what could we do?
I think the kids call it, yeah, this has been asked for me a couple, but it was a couple years ago that the kids say, like, are we cooked? Right? Like, is that
R-
the end?
Yeah,
I don't know
right.
how the Gen Z slang kind of goes. Here's the thing. So in 2024, we recorded the Earth's hottest temperature ever. A lot of that was because of human caused climate change. Part of that, though, was because we were coming out of El Nino, which we know
Mm,
that drives up that global temperature. So, those two in tandem, what that did is for the first time push Earth's temperature above that 1.5 degrees Celsius that scientists have for so long told us that we need to keep the Earth below. We're not stuck there, though. What that showed us, though, is that the extreme weather that defined 2024, that's the world that we're potentially setting ourselves up for. Doesn't mean it's going to impact you every single year, but we saw the floods, we saw the hurricanes, we saw all the extreme heat events that did impact a lot of the globe. 2023 is year number 2 in terms of the Earth's hottest. As of right now, I just saw some recent data from Copernicus that say that they think that 2025 is going to tie 2023 as the second hottest year of record. Berkeley Earth said if it's not number 2, then it's going to be number 3. The point of this is that we understand and we see the extreme weather that we're experiencing today. So, back to the question of are we cooked? Is there anything that we can do? I always say that yes. The answer to that is yes. Like, I'm not going to sit here and talk about climate change and tell you about all these, the data that spells out how bad things are. There is still things you can do. So as you and I, as a super just one human, things we can do is cool down our cities first. We understand that there's climate change. We understand that there is urban heat island effect that adds on top of that. That's the built environment, buildings, cars, asphalt, the air conditioners that are keeping us cool
I
because,
think that's
yeah,
something a lot of people can just understand simply, right?
right. Yeah.
Yeah.
So we can build our cities different. We can add back in native vegetation. That's going to help bring down temperatures a bit. That's going to help with when we do get an extreme rainfall event. It really helps to mitigate that water just rushing on the concrete we've built. The other thing about it, and the biggest point I always stress is what we are doing today. Conversation and communication are a solution to climate change. I think that's a solution to a lot of the things that we're
Mm.
butting heads in society these days, like if we could just talk better together, then that would solve a lot of problems because you can just start the conversation. Even if you don't see eye to eye, at least you're talking. We're going to find some common ground because we have more common ground than not. And that's, again, climate change or anything. And then we can work towards solutions. The big thing, and I want to stair step us up here. We know that burning coal, oil, and methane gas, that is the biggest reason, the reason that we are where we are, that we as humans have exponentially warmed our planet on the timeline that we have. So the ultimate goal is to draw down that carbon pollution, to move away from fossil fuel use through our electricity, through our transportation, and bring up our renewable energies. That's wind, that's solar, that's all the different ways that we can create energy and still live the life that we live today, but without putting that carbon pollution into the atmosphere. It's not an automatic switch, right? You're
Mm.
not going to switch out one for the other right away. But that's what we know we need to do. And that's a big problem. That's not a Florida problem. It's not just a United States problem. This is a global thing that we have to work on together. And again, it goes back to those conversations, communications. There's a lot of global conferences. There's one called COP, Conferences of Parties, that just happened in Brazil, right? This is where world leaders come together, and we need to come together in order to solve it globally. That's the big part. And that sounds really hard. So that's why I want to bring it back down to the things that you can do as a human, because even if you're just one person, you do matter. And I always like to say, let's go back to that native plants part. Let's say you plant something native to you there in Florida, in your front yard, and your neighbor is walking their dog down the street, and they look at your yard and they go, "Oh, those are cool. I really want those in my yard too." So now you've become this like real life influencer, and maybe you've started these conversations in your own neighborhood, and then you start to see more and more of that pop up. And then you start to say, okay, let's go to our HOA or let's go to city council and let's talk about the things that we can do in our cities. So just because you're one person doesn't mean that you're negligible in terms of how to deal with climate change. It's that snowball effect that we can continue to grow together.
I like that attitude. It's very positive. I am gonna just I do want to on the conversation part of this. So ask you a question I get asked all the time,
Yeah.
and maybe you can kind of give me. I know it's a complicated one, but you've kind of already touched on it. You definitely have already touched on it. Is when people say, well, the climate has gone up and down. There's been these swings. That's part one of the question. Part two is a lot of people say to me, especially in the United States, are like, well, we only have weather records to go back 100 years, which I think I heard you already touch on this. But how do we know that right now the climate is influenced by us if we only have official records that go back 100 years? How do we know what it was like 1,000, 10,000 years ago?
Okay, so let's start with the 100 years. Yeah, where I am, we have records that actually go back 142 years. They go back to the late 1880s. So one thing that we know, yes, there are natural variabilities in weather, especially, and that's really what this attribution science is picking apart that natural weather variability from the added influence of human-caused climate change.
Mhm.
So what I always like to say, and we hear this so often around cold weather events, if you look and you say, "Oh, it's really cold outside," or "It's like unusually cool today," or something like that, like what happened to climate change? That's always the
Oh,
first comment.
every time.
Yeah. So what I like to do is, yes, the United States has one of the gold standards when it comes to weather data record keeping on this planet. So we have a really good confidence in the data that we have kept. And so what you'll look at, and you can go to climatecentral.org. We've got this tool that updates daily as the National Weather Service updates their information. But it's a record tracker that goes back to the late 1800s. And what you'll see is going through the late 1800s, the early 1900s, is that there is a back and forth between record heat and record cold. That's what you expect. That's that natural weather variability. But for a lot of our cities in the United States, what you'll notice is around some of us for the 80s, but especially the 90s, the 2000s, and then particularly the 2010 and the 2020s, you'll notice that the record heat is far outpacing record cold. It's important to note, we'll pause here for a second to say that there is still cold air and there is still extreme cold, even in a warming world.
Hmm.
We do, for the time being, still have ice on our poles, right?
Yeah.
Um, so you can still get very cold weather, but we understand that the record heat is far outpacing that record cold. So that's that first piece of like just 100 years of records. So how do we do this if we only can go back to the late 1880s in terms of temperature records? How do we know? How do we know that this is the fastest increase of CO2 on the Earth's timeline? We have those observations from places like Mauna Loa, where they were keeping for the longest time. It has seemed to, at least the data has been paused for now, to understand daily what CO2 levels are in the atmosphere, along with other, that's not just the only spot in the globe that we've been monitoring that. But we have that record. We have core samples. So we can drill down into ice, we can drill down into the earth. And from that, scientists can look back at the different climates and the different weather that has happened over the creation of Earth, from the dinosaurs to us and even beyond. So we can look at all that and we can recreate these climates. And yes, there have been colder periods. Yes, there have been hotter periods. That's the natural variability of Earth. But again, when you look at the data and you look at the trend line, you see that the CO2 that's going into our atmosphere is a sharpest rise we've ever experienced. And that temperature correlation goes right along with it. And that's how we know humans have had an impact. And we know that's the beginning of the Industrial Revolution, that when we started seeing that rise.
All right. Well, thank you very much, Shel, for talking with me on this attribution science, how this relates to climate change. I can't thank you enough. Before I let you go, though, if anybody wants to get more information on this and they want to find out just everything you've talked about here, some more resources they can learn, where can they go?
Yeah. And I hope that you do. If you've listened to this and you're like, if you still don't quite think that this is a science, I do want you to go and look, read it through, and I'm happy to talk more about it with you at any time. Climatecentral.org, click on our resource section, and you'll find the release we put out about attribution science. If you, while you're there, look at the climate shift index, what that's going to do is give you attribution science for the temperature that you're walking out the door to today there in Florida, but it also does it globally. And then you can also look at that ocean temperature. And, that's what we have currently. But in 2026, we plan to come out with more rapid attribution. So we'll be able to do things like the humidity you feel there in Florida, maybe the precipitation by late 2026 is a hope. So there are more attribution sciences in real time that we're working on so that it can inform you each and every day as you start your day, just the way the forecast does.
All right. Well, thank you very much for talking with me here, and yeah, it's interesting stuff and some lot of research and science you guys are doing there at Climate Central.
Yeah,
Thanks, Shel.
appreciate you having us. And anytime, always happy to chat.